Okay, so if we look at our game right now for a quick recap, we have this cursor which is moving around. We still have that crash if we go out of the bounds of the screen, just because we're specifying the position in terms of pixels. So if we're going to like negative pixels, we're obviously going to hit an issue because we're going to be going out of bounds for our memory. So what I want to do today is go ahead and get some text rendering on the screen, which is a bit more complicated than it sounds, though the way that we're going to do it is, well, there's a few things. One thing, we're going to get some help from some code that another game developer wrote, which is, a very widely used tool that a lot of other indie game developers and probably even professionals use in their work. So you get to see an example of some code written by someone who isn't me and someone who's a lot more experienced than me by, at this point, probably like 35 or 40 years. So that's pretty cool. And we also get to look at the way that we would do this in a professional sort of way, right? So you could imagine that we could sort of hack in fonts, right? Because we have these sprites, which are nice, and we could go ahead and define sprites for some very low res fonts, right? Like if we wanted to, we could probably go in here into our art program, right? We could go ahead and place. Well, even that is pretty small. So let's go right here. Let's set one. Why can't I just type in there? There, that's pretty annoying. We do like 1 pixel and 2 pixels. We do something like that and draw that, and that could be like our A. We could do something like that in code, right? That's not that many pixels. It would be a lot of typing, but we could do it. Now, it would certainly be a pain because we would have to do that for all of the letters. And, we probably just don't want to be typing out code like that, especially when the results aren't that great. Like, I'm all for going about doing things the hardest, most time intensive way possible, as long as the results are really good. But here, the results would be really, really bad. And I'm not an artist, I'm not a font designer, so even ignoring the fact that I would be typing out code, doing it a pixel by hand, I probably wouldn't even have a very good idea of how to make that look good given the constraints that we have. So, what I can do though is go ahead and download a font. So, this is the font I went ahead and chose. I downloaded it from right here. I'll put this up on the downloads page for all of the videos and stuff, so you don't have to worry about downloading it right now. But this is an example of a font. We can see, here are all sorts of letters. And we can download the TrueType font. Now, what we want to do is go ahead and um, I will I'll get rid of this scratch buffer that we've been using. I'll go ahead and put down our goals for today. We want to read a font from disk. So that means that the font is going to be in a file format that we want some code that goes ahead and reads the bytes from that file and knows how to interpret that data, right? Then we are going to get the font into a bitmap, right? That's kind of the same thing as reading it from the disk. We essentially want to convert that font, that TTF file that we just downloaded from the internet. We want to go ahead and convert it into a bitmap that we know how to work with. Because once we have it into a bitmap, we can go ahead and start drawing it onto the screen. Then what we want is to access parts of that bitmap to draw individual letters and symbols, right? So, what we are going to do is go ahead and look at, and again, I will go ahead and post this all online. So right here, we have this file called stb image. Or sorry, that's the wrong one. I want stb true type. Let me go ahead and increase this. So this is some code. You see it's a .h file that we can go ahead and include in our project. It's written by someone who's been in the games industry a long time. They wrote a lot of very helpful libraries like this that are also very small and lightweight. They're easy to go ahead and include into our project, so we're going to look at that. I'm normally not somebody who likes using other people's code. I kind of like understanding problems myself and dealing with everything, at the lowest level that I possibly can. This guy just writes really, really helpful code, which makes my life a lot easier. And it's code that I can trust. It's code I can understand, and that really gets out of my way. It makes it very easy to use the code, whereas a lot of other libraries that people write, it can actually sometimes be more complicated to understand the code that they wrote rather than to just learn how to write it yourself. So this is about 3,000 lines of code. So far, this is probably the biggest thing that we've seen. Like, our game right now is at about 500 lines of code. And, that's a lot of comments. This file also has a lot of comments. Like, if we go here and we look, that's like the first, 250 lines is comments. Then we have a fair number of comments throughout. So part of the reason to go ahead and use this code is this format, this TTF format, is let me go ahead and pull this up. TTF format, TrueType, right here, the Wikipedia. So it's a font standard developed by Apple and Microsoft in the 80s. It's been around for a long time. A lot of fonts are designed in this format. So it's good to go ahead and be able to use this. I think it'll just make our lives a lot easier. And this way we can also go ahead and download various fonts and use that in our game. So that can be nice. We could get a bold font or an italics font, things like that. And we don't have to design all of these by hand. I'm going to go ahead and undo that so we can start using this to draw for the day. All right, so first things first is if you're following along at home, you'll want to go ahead into the Google Drive and download this file. If you're watching this video some point in the future, maybe I don't use Google Drive anymore because I found a better solution. In which case, I will make sure that I post it there. So we can look at this and see there's all these comments which are sort of defining how we're going to use the tool. The thing that we really care about right here is this thing, this bake font bitmap. So a lot of times in programming we use the term bake to mean essentially something that takes a process or takes some data and does some operation to it and then produces new data which we can then use. So we don't have to always go ahead and bake the font bitmap. Once we bake it once, we get this bitmap, and then we can use that all on our own without even worrying about this STB thing. Sometimes people will refer to baking light maps, right? Because if you have a big 3D game and you're trying to determine where the lights are and which things are lit and which things are dark, that can be very computationally expensive. So you bake a light map, and then you can just go ahead and use that without having to do that process all the time. So what we are going to want to do is go ahead and include this file. So first things first, you're going to want to make sure that it's in your project directory. So right now, here is a list of my project directory. We have our game file. We have our compile.bash. I have all of these fonts. You don't need those, really. I also have the zip file in there. That's kind of gross. I should get rid of that. And then I have some of these STB files. Right now, the only thing we care about is TrueType. I just have these in because they are things that I often use. Maybe we will use them. Maybe we won't later. So don't worry about that. So all you want is this file that is, what is it? Deja Vu Sans Mono TTF, and then STB TrueType, right? So if we go into our game, I'm gonna say that the first thing we're gonna do is go ahead and load up this bitmap. So what we are going to want is a few different things. First of all, if we go ahead and look at this TrueType header file, we are going to want to include this in the project, right? So let's scroll up to the top. We can go ahead and do this after our types definitions. Let's go ahead and include, and again, this is a file in the project, so we use the quotes to be TrueType.h. One important thing to note is, let's see, yeah, the license. This software is dual license in the public domain, so you are granted a perpetual irrevocable license to copy, modify, publish, and distribute the file as you see fit. So this guy was very nice to give us the code, say, hey, you can use this any way that you want to. So we can just go ahead and copy paste that into our directory. And then we'll include it right here. One other thing that we need to do is we need to define a macro, stb TrueType implementation. And this is just something that he tells us that we need to do so that his code can work properly. So we'll go ahead and do that. Then we know that this is the function that we want. It bakes a font to a bitmap for use as a texture. Texture is a term kind of used synonymously with either bitmaps or sprites. Textures are really what's used in 3D, so there's a bit more complicated math involved with it. For our purposes, though, don't worry about the fact that he says texture instead of sprite or bitmap. We'll be using it just as one of those. So if we go ahead and into this file, we can go ahead and search for the definition of our bake font bitmap. And you can see it's not a whole lot of code. It's calling these functions that he wrote, which are probably a little more involved than what's right here. But we can go ahead and look at the things that it needs. So it's going to need a pointer to some data. It's going to need the height of the font. It's going to need the pixels, which is the bitmap that it's going to write into. It's going to need the width and the height of that. It's going to need the first character, and it's going to need the number of characters. So we can just go ahead and call that function, and then we can start filling things in as we go along. So let's go ahead and ignore the data for right now. We can also go ahead and ignore the offset, so we'll just pass in 0 for that. All right, then we are going to want to make a uint8 pointer to, let's call this font bitmap, and we'll go ahead and want to allocate some space. Right now, we don't really care how much space. That's not what's important. We just know that we're going to need to allocate some at some point. Well, we can go ahead and just fill some of these things in. So we can say, let's take a uint8 or uint32 for the font bitmap width, and let's just say, I don't know, it's going to be 512. And then we can do the same thing for height. So we'll do 512 by 512. And keep in mind, this is going to be a bitmap that's going to have all of the letters that we are going to use in our game in it. It'll probably have even some that we might not use. And then let's also go ahead and define the size. Font bitmap size is going to equal the font bitmap width times the font bitmap height. And now we know how much we want to allocate, right? We can say font bitmap size. Now, if you are particularly astute, you might notice that so far when we've allocated bitmaps, we've needed to multiply that size by 4, right? Because we want 4 bytes per pixel. The way that he is using the term bitmap and the way that makes sense to use it for fonts, really, is to just go ahead and say that we have a grayscale image, right? So all it is just a pixel is either black or it's white or some value in between. So we only need 1 byte per pixel, right? And if we go back into this, like I started drawing, we can maybe see why, right? Where, we just want to say what constitutes the shape of the letter, and then later we can worry about what color we want to make that letter. All we really care about in this bitmap is like, hey, should I draw a pixel here or should I not draw a pixel, right? So we don't need to worry about multiple colors at this point in time. So that's going ahead and making the font bitmap for us, where we are going to give him a pointer and he's going to write some data into it, right? So let's do that. And then you'll see he's also requesting the pixel width and pixel height. So font bitmap width and font bitmap height. All right, so the other things that we care about are the first character. Well, if we go ahead and pull up the ASCII table right here, we can see that all of these characters aren't really things that we can draw. Like, how do we draw an escape? How do we draw a carriage return, right? So 32 is really the first character that we care about, right? So let's go ahead and say that that's the first character. And then we want to know how many characters later. So I'm going to make a couple of variables here. We're going to say start ASCII, which I'm going to make 32, and then uint32 end ASCII, which I'm going to say is, we can do 126, or really 127, right? 127 right there. And then we can make a variable that's going to be the number of characters. I'll just call this num characters. That's going to be the end ASCII minus the start ASCII, right? We can go ahead and pass those in, start ASCII, and then num. I like char count more than num characters. And then the last thing we want to pass in is this thing, which is stbtt baked char. So we can see that's a type. It's a pointer to a type that we don't know what's in there yet. So let's go ahead and look for the definition. Baked char. So right here, we see we have this struct. The definition might look a little different. Don't worry about that so much right now. Really, this type def is just so he's able to say stbtt baked char without putting struct in front of it. Yeah, so don't worry about that too much. We might start doing that in the future. I didn't want to go ahead and overload that. But if you at any point get tired of writing structs like that, right? If you want to start doing something like this, and just say, hey, player equals whatever, player.x, etc., then, feel free to go ahead and do that. All right, so we are going to want to make one of these, right? So, because again, he's asking for a pointer to it, which means we need to have made it an allocated space for it on our own. So I'm going to call this baked chars and going to say stbttt baked char pointer, and we'll do malloc. So I want to do size of stbtt baked char times the char count, right? And then I'll go ahead and give him a pointer to that. This is also something we could have made this an array if we wanted to and just done like stbtt baked chars of char count, right? We could definitely go ahead and do that if we wanted to. I prefer just going ahead and doing the malloc right here and not worrying about the fact that it's an array. Just saying, hey, we're reserving space for it. Okay, so now the thing that we need is we need this unsigned char data, which is the font location of our file, right? So what we're going to need to do is read in the TTF file. We need to tell the computer to look into that file and copy all of the bytes in that file into a buffer that we are going to make right here. So let's go ahead and say, and again, remember, a uint8 and an unsigned char are the same thing. I don't know necessarily why he prefers this naming convention, but I definitely prefer uint8. I think it's just a lot clearer what's going on. So we'll go ahead and do that. So we can call this the TTF buffer. And let's go ahead and say that we allocate some number of bytes. Now, this is an interesting question because we haven't read the file yet, right? We don't even know how to read a file yet. We'll see that in a second. But we don't know how to read a file, so we don't know how to know how big that file is, which can be kind of a problem, right? So I think what we can go ahead and do is just make it big enough that we know that reasonably we probably will not ever encounter a file that's so big that we can't fit it into memory, right? And it's totally fine to allocate more memory than you need. In fact, as we get further into the game, that's something we're going to be doing all of the time. We're going to be allocating so much more memory than we need. And, later on, you can go ahead and, pare that down a little bit if you're going to release the game. But just for development process, it makes a lot of sense to allocate more memory than you need so you know that you never run out, right? So what we are going to do right here is say that we want trying to think what the best way to do this is. Probably the best way is to go ahead and remember malloc takes bytes, right? So let's go ahead and go here and look up I don't know, what is 32. 32 is huge, actually. Let's say, what is 8 megabytes in bytes, right? Well, okay, that's pretty big. In fact, actually, we can just go ahead. We go and do our terminal right here. If I do ls-a and look at our deja vu sans mono file. So we see this is 328 kilobytes, right? So let's even say that we just have, I don't know, 2 megabytes, right? Well, that is going to be what? That's like roughly see right here. If we go ahead and just look at what we need for this specific file, 328 kilobytes. So that's 328,000 bytes. So let's just go ahead and say, hey, 1 kilobyte is 1,000 bytes. So we will say TTF buffer size. That's going to be 1,000 bytes times 1,000, right? So, and we can even say, I don't know, 10,000. That's a lot. Although really, just realized, really we want 1,024, right? Times 10,000. Let's go ahead and compile, see what terrible things happen. Oh, well, one thing, we forgot to give it the TTF buffer, right? So now, sorry, I'm just going to close my door. All right. Saying incompatible type for argument 3. Saying that or font bitmap width is wrong. Oh, I think this thing expects them to be ints, doesn't it? Oh, and yeah, and pixel height. That's right. Yeah, we want to go ahead and define how many pixels tall our font is going to be, right? And so this is just going to be a universal size used by all the letters. And if the letter is very small, like a capital versus a lowercase letter, then it's still going to have enough space for that. It's just, all of that unused space is going to be empty, right? We just aren't going to use any bits in there. This is what's known as a float. And a float we will see probably a lot more of later. Right now, all you need to do is think of it as a real number. So that's going to be a number between negative infinity and positive infinity that is not a whole number, right? So like, if I say right here, font height, that could be 12.0. We could also have 12.05, right? And notice I use this F at the end. That is just to denote that, hey, the thing I'm typing out, it's not a number, period, number. It's, it's a number with a decimal part, right? So, I don't know, let's just do 32.0 for this. This needs to be the third thing passed in. So we'll call this the font height. We'll call it even font pixel height, just so we're much more specific, right? Okay, cool. We run. Let's go ahead and see what happens. Or sorry, we compile. Let's go and see what happens when we run. Okay. Not a whole lot. In fact, really nothing different than before. Luckily, we didn't crash. The issue, though, is that right now we have this TTF buffer, which is pretty big, but we don't have a way to read the file in yet. So that is what we are going to want to do, and we can go ahead and look at a function in C called fopen, which stands for file open. And it opens the file whose name is specified. So, and it returns, you see, a pointer to a capital file type, whatever that is. So what we are going to want to do is say, hey, we have a file here, TTF file. And again, there'll be a pointer. And we're going to say that that equals fopen. Let's see, what does this take? It takes a const char. Don't worry about really what const means. It just means that the pointer isn't ever going to change. So it means, hey, when you make a const char star, a pointer, you're just saying this is a pointer to memory, and it's never going to change, whatever is there, right? So let's do fopen, and we are going to just say deja vu sans mono.ttf, right? And now let's look at what this mode means. So if we look here, it's a string containing a file access mode. Well, it's going to be read, write, append, read update, write update, or append update. And we can see there also, in order to open a file as a binary file, a B character has to be included in the mode string. And that's what we want, right? Because we want to be reading this file as if it were just a stream of bytes, and then putting those bytes into this buffer. So we'll go ahead and just say R for read, and then B for bytes, all right? So that goes ahead and gets us the file. It opens it for us. But now we need to go ahead and read it. And for that, we will be using a function called fread. You see, this is going to, it takes a file, it takes a pointer to some data, it takes a size, and it takes a count. And it's going to read all of the elements from the stream into that pointer. So if we go ahead and do this, we can say, all right, fread. So our pointer is going to be the TTF buffer, right? And let's see, the size in bytes of each element to be read is just going to be 1, right? Because we're reading in a byte at a time. You could imagine we would do this if we wanted to read into like an array of integers, right? We would say 4, and we would read 4 bytes at a time and put it into the buffer, right? Then we're going to do TTF buffer size, like that. And then we are going to give it the file that we want to read from, right? Let's go ahead and compile. Again, we run, and nothing particularly interesting happens, which is fine. Because we haven't done anything with our bitmap yet. So go ahead and, if you're having trouble understanding or following this, go ahead and, maybe even watch this video again. This is the first time we've really done anything particularly complicated with code that we haven't written ourselves. And it's also throwing a lot of new concepts at us, right? Where, we're doing some things that we still probably aren't comfortable with yet, like allocating space. We're still kind of getting used to that. We're doing a lot of stuff with pointers. We're opening files, and then we are writing into those files. And then we're passing in that data that we read in, and we are passing that into other functions, right? So it's a lot of stuff. If you're having trouble following, don't worry about it. Like I said, maybe go ahead and watch the video again. Go ahead and think about it. And as we get further in the next video, I think the exact process of what's going on will start to become a little bit clearer once we start to see some results.